A quadratic function is where the variable, the independent variable, is raised to the second power. Okay, let me give you an example. Here's a quadratic function. This quadratic function, okay, so let me see, f of x equals to x squared. No, let me say like this. Well, x squared, that's the basic one. That's the basic quadratic function, okay? Can we graph this? Sure we can. It's a parabola, okay? So here we go. Look, so here's x, and then we have f of x, okay? So if x is 0, what's 0 squared? 0. If x is 1, what's 1 squared? 1. If x is 2, what's 2 squared? 4. If x is 3, what's 3 squared? 9. How about if x is negative 1? What's negative 1 quantity squared? 1. What's negative 2 quantity squared? 4. What's negative 3 quantity squared? 9. So look, when x is 0, we get 0. When x is 1, we get 1. When x is negative 1, we get 1. When x is 2, we get 4. We get 4. When x is negative 2, we also get 4. When x is 3, we get 9. I'm going to say that's 9, okay? And when x is negative 3, we also get 9. I'm going to say right around there. And so we get this. Whoa. Let me do this. 9. Okay? Do this again. There we go. And so we have this parabola. We call this a parabola, and it should look better than this. There we go. It's a parabola. Okay? It should look a lot nicer than this. All right, so here we go. Yeah, that's better. And so this side is it's ugly, to be honest with you. And so therefore, let me say like this, it's a parabola. There you go. Okay? Parabola. And this is the basic parabola. It's a basic one. It doesn't get any easier than this. This is f of x, and this is x. This is the basic parabola. It's a function. And here is the table. Now, it does not get any easier than this. By the way, we call this the vertex. This right here is the minimum. The minimum point, we call it the vertex. In this case, the vertex is 0, 0. That's the vertex. Okay? And so, the basic parabola. Now, let's mess around with the basic parabola. Watch this. We can mess around with the basic parabola. Okay? So, we have f of x. Watch what happens when I take x. Here x is being square. X I call the argument. Okay? And so, x is the argument. X is the argument, okay? And watch what happens when I take the argument. Here the argument is being squared. The argument is being squared. Watch what happens if I take the argument and I come up with a new argument, okay? Here I'm going to take this argument x. I'm going to take this argument, watch what happens. Take the argument, and I'm gonna add or subtract to the argument. Here I'm gonna add 2. Add 2. So this x plus 2 is the new argument. And I'm gonna take this new argument and square it. Okay? The x argument is being squared. The new argument is being squared. The new argument is being squared. So x plus 2 is, look at this, the argument now. So here we took x, the old argument, and we added 2. Okay? So I should say like this instead. We took the old argument and we added 2 to the argument. That's it. We added 2 to the argument. Okay? And here it is. That's the new argument. And I'm going to call this, let's call it a different name. Let's call it g of x. It's a function. Okay? Let me just tell you what this would do. We know this is a new argument because it's being squared. This is x plus 2 is being squared, okay? What this would do, what this 2 will do to this x squared, if you add 2 to the old argument and you square all of that, that's going to shift this parabola 2 units to the left. If you don't believe me, we're going to make a table. Watch this. Let's make a table. So here's x, and here's g of x. Watch what's going to happen to the old parabola. This is the basic parabola. This is x squared. Watch what happens when you add 2 to the argument. And now the new argument is being squared. Watch what happens. So let x be, watch this, let x be -2. Okay? What's -2 plus 2? 0. What's 0 squared? 0. Let x be -1. What's -1 plus 2? 1. What's 1 squared? 1. Okay. Let x be 0. Okay. 0 plus 2 is 2. What's 2 squared? 4. Okay. All right. If you want to, let x be 1 now. 1 plus 2 is 3. 3 squared? 9. Okay, let's go down this way. Let x be -3. What's -3 squared? I'm sorry, what's -3 plus 2? -1. What's -1 squared? 1. Let x be -4. What's -4 plus 2? -2. What's -2 squared? 4. Let x be -5. Okay. What's -5 plus 2? -3. What's -3 squared? 9. Now we're going to graph this. Okay, watch what happens, okay? Watch what happens when you add 2 to the argument in the parabola. How do I know it's a parabola? Well, because the power is being squared. If it was being cubed, it's no longer a parabola. And that's what it looks like. Watch what happened. Now we're going to graph this one. Okay? I'm telling you, when you add 2 to this parentheses inside in a parabola, when you add 2 to the parentheses, to the variable in the parentheses, and that's being squared, that's a horizontal shift. is 2 units to the left. It's in the opposite direction. Now, this is gonna reflect that, okay? So watch this. Let x be -2. What's g of -2? 0. X be -2, that's 0. See? Let x be -1. G of -1 is 1. X be -1, and we get 1. Okay. See? Let x be 0. G of 0 is 4. G of 0 is 4 right there. You see that? You see what's going on? Let x be 1. G of 1 is 9. Let x be 1 and we get 9. 1 and we get 9, right around there, okay? That's only an approximation, guy, okay? Let x be -3. G of -3 is 1, look. X be -3 and we get 1 right there. Let x be -4. -4 and we get 4. When x is -4, -1, -2, -3, -4. And what do we get? We get 4 right there. Okay? Let x be -5 and we get 9. -5 and we get 9 right around there. And so we got this, look. Oh, this one moved. You see? So, what did we learn? We learned that if you have a basic parabola and you add or subtract to the argument that's being squared, to that argument that's being squared, it's a horizontal shift. In which direction? In the opposite direction. This is x plus 2. We went left. Look. Okay? When you add to the argument, it's a horizontal shift in the opposite direction. Okay? I bet you if I say x minus 2, it would have moved 2 units to the right. Okay? Very good. Now that's adding to the argument. Here's another one. Here is another one. Watch this one. Here's another function, okay? X squared plus 3. And what should we call this? We should call this, here I have f of x, the basic one, g of x, which is a horizontal shift. And let me call this h of x. Okay, watch this. You see this x squared? This is f of x. So here I'm adding 3 to the function, not the argument. So here we added 3 to the function. Okay? Here we added 2 to the argument because we did it to this x, and now this new argument is being squared. But here, x plus 3 is not being squared, no. This 3 is added to x squared, different. So here, this 3 is being added to the function f of x. This is f of x. That's why. If you want to make a table for this, you can. But let me tell you guys, when you add to the function, it's a vertical shift. Okay? It's a vertical shift. So this goes up. Okay? So when you add to the function, it's a vertical shift, not in the opposite direction. Let me make a table. Watch what. This is the basic parabola, and this is the parabola shifted. This red one is the basic parabola 2 units to the left. And now this one is going to be the basic parabola 3 units up. If you don't believe me, we can make a table. X and h of x. If x is 0, what's 0 squared? 0 plus 3, 3. If x is 1, what's 1 squared? 1 plus 3, 4. If x is 2, what's 2 squared? 2 squared is 4. 4 plus 3 is 7. If x is -1, what's -1 squared? 1, and 1 plus 3, 4. If x is -2, what's -2 squared? 4, and 4 plus 3, 7. There you go. Let's graph this now. This is gonna be the basic parabola 3 units up. Basic parabola. Watch this. If x is 0, we get 3 right there. If x is 1, we get 4. X is 1 and we get 4 right there. If x is -1, we get 4 right there. Okay. If x is -2, we get 7. X is -2, we get 7. 1, 2, 3, 4, 5, 6, 7. -2, we get 7. -2, and we get 7 right there. If x is 2, we also get 7 right around there. And so this is what we're getting. Okay. Okay. So this is, look, from here, we went this way, now we have a new vertex. This is, what's the vertex here? The vertex here is -2, 0. Okay. What's the vertex for this one? This is h of x. What's the vertex? 0, 3. Okay. So here's the point. When you add to the function, it's a vertical shift, not in the opposite direction. When you add to the argument, look, this new argument is being squared, it's a horizontal shift in the opposite direction. Okay, very good. Okay, all right, so we need the room now. We need the room, okay? Okay, don't forget, the basic parabola. I'm going to leave the basic parabola right there. What's going to happen? Let me graph it again. So here's x, and here's f of x. And what does the basic parabola looks like? Well, the vertex is right there, and then 1, 1, and then -1, 1, and then 2, 4, and then -2, 4. And then we have this. That's the basic parabola. Okay, don't forget the basic parabola. All right, so watch what's going to happen. Watch this. Okay, so this is x plus, let me say minus. -3 quantity square minus 2, and this, I'm gonna call it, what should I call it now? Can I call it Rx? Sure. Okay. All right. So this is the basic parabola, 3 units to the right, 2 units down. Okay. This is a horizontal shift in the opposite direction. This is a vertical shift not in the opposite direction. Okay. So let's graph this one. So watch this. This is the basic parabola. 3 units right. Okay. 3 units to the right. 2 units down. Basic parabola. Here's the vertex. 3 units right. 1, 2, 3, and 2 units down. 1 and 2. Whoa. And that's the new vertex. Okay, so this really tells me the new vertex. 3 units right. The basic parabola, 1, 2, 3 units right. So this one is telling me the new vertex, and 2 units down, 2 units down. So therefore, take this 3, take the opposite of this, and then do not take the opposite of that, and that's the new vertex. This is the vertex. Right there. The new vertex right there. It's the opposite of this and not the opposite of that. And so now we say from the vertex, whoa, 1 right, 1 up. 1 left, 1 up. Twice right, 4 up. 1, 2, 3, 4 up. Twice left, 4 up. And so now we're getting this. Oh, always mess up. There you go, that's better. So that's the new parabola. Okay, so therefore, the opposite of this, not the opposite of this, is the new vertex. Okay? So that's why I took, this is -3, I took 3. This is -2, I took -2. And that's the new vertex for this parabola. Okay? They call this the vertex form. This parabola is the right here, the way this is written, is the vertex form. Why? Because you can see the vertex. That's why. You can see the vertex when you have it in the vertex form. Okay? Let's do it again. You want to do it again? Sure, we can do it again. Watch this. I'm going to say L of x equals to x plus 1 quantity square plus 5. Can you give me the vertex? Sure. What's the vertex? The vertex is -1, comma 5. Okay? Now look. When the leading coefficient is positive, it opens up. If the leading coefficient right here, if this is ever negative, it's going to open down. Okay? So therefore, this one opens up because this is positive here. It opens up. So the vertex is a minimum. This one here is a minimum. Look, a minimum. That's a minimum. So this vertex here is a minimum. If it opens down, the vertex is the maximum. Okay? Very good. Okay. Now, so this is in vertex form, right here. Can you graph this? I'll let you graph this one, okay? It's the basic parabola. It behaves exactly like this one, except that it's gonna, that's a new vertex, go to this vertex, -1, 5, -1, and then 1, 2, 3, 4, and 5, and that's the new vertex. And what's the behavior of this? From the vertex, look, one to the right and then one up, you land on the graph. From the vertex, one to the left, one up, you land on the graph. So therefore this one to the right, one up, one to the left, one up. Okay? Twice to the right for this one, twice to the right, how many up? 4. So twice to the right for this one, how many up? 4. 1, 2, 3, and 4. Twice to the left, how many up? 4. And this is the new parabola. Copy this one. Okay. So this is in vertex form.